Alright, section 3.4, we're going to be looking at exponential and logarithmic functions and basically solving expressions involving these. So the first couple ones we have a tactic where we try to make the bases match. For example, this is a 4 to the x is equal to 16. So if it's possible, remember if you have like bases, we have some properties that work. If we can rewrite 16 to have a base of 4, we might have some things that we can work with. So how can I rewrite 16? 4 squared. So then now when the bases match, we can just set our exponents equal to one another. So that allows us to say x is equal to 2. Okay, trying to rewrite these to the same power. So first of all, we have a 2. Let's rewrite these. This is 2 raised to the 7 minus 3x as the exponent is equal to 1/4. Now, our directions tell us to try to write with the power of the same base. So we want to have a same base. Well, we know this one's a base 2, and out of 1/4, we could possibly work with this 4 to get a base 2. So let's work with that 1/4. So 4 is 2 squared, right? And how can I rewrite 1 over 2 squared in the numerator? 2 to the negative 2 power, right? Good. So then now let's bring this side down as is. So that gives me 2 to the 7 minus 3x power. Basically, we're going to manipulate one side or the other of the equation so that the bases are going to be the same. So then we can say when the bases match, we can set the exponents equal to one another. So then we would get 7 minus 3x is equal to negative 2, and then we're just solving an equation. So solve for x. And here we divide both sides by negative 3, and we find out that x is equal to 3. Okay, I rewrote this so you can see where the exponents are. I want you to try to rewrite these to have the same base. And then equating the exponents as the directions say. 16 can be 4 squared, and then this exponent was already there, so leave it there and put it in parentheses. 64 can be rewritten as 4 to the 3rd power times the exponent that's already there. And when these bases match, we can set the exponents equal to one another. So let me move this out the way. So we can now evaluate 2 parentheses x plus 6 is equal to 3 times x minus 8. So let's go ahead and distribute this out and solve. 2x plus 12 is equal to 3x minus 24. You can solve this however you like. This isn't the only way, but so I get negative x is equal to negative 36. Divide both sides by negative 1. And I get x is equal to 36. Okay, let's try this one, which is e to the x plus 8 minus 1 over e to the 4th power. First thing is, how can I rewrite this one? This is equals, sorry. Equals, good. So first thing I want to do is rewrite this one as e to the negative 4. Remember, if you move it from the denominator to the numerator, the exponent changes sign. And then we get e to the x plus 8. Well, now our bases match. So we can just say x plus 8 equals negative 4. And then we solve for x. Simply x equals negative 12. Okay, so solve the exponential, express the solution and set, it's a solution set in terms of natural logarithms. Okay, but first of all, let's consider what we've done previously to solve these is we tried to make the bases match. So then we can set the exponents equal to one another and solve. In this particular case, there is no way I can manipulate this so that it has same bases. So um, other than the fact that it told us to evaluate in terms of natural logs, we can take our equation and let me rewrite it. E to the 4x is equal to 7. And to solve one in this case, we would take the natural log of both sides. Whatever you do to one side, do to the other. Now we will use our properties. What about this particular exponent? What can we do with it? Use our power rule, right? Let me put it in a different color and move this to the front. So it becomes 4x times the natural log of e is equal to natural log of 7. Okay, I want you to recall, what is the natural log of e? Recall, natural log of e equals 1, right? Because there's that known base e here, so e to the e power is just the exponent, which is just 1. So recall that piece of information. And if this is just 1, what we have left is 4x is equal to the natural log of 7, and our goal is to solve for x, so we divide both sides by 4. Now, in my math lab, this is considered your exact answer. And then if you put this in the calculator, natural log of 7 divided by 4, x is approximately 0.4865. This is an approximate answer. So sometimes it asks for the exact, which would be this expression, and sometimes it asks you to give the approximate, which means put it in your calculator and solve. Alright, let's look at number 6 and see if you can solve this one as well. If you're not able to rewrite with the same basis, so then we're going to have to use natural logs because it told us to. So it would be natural log of this side of e to the x plus 4 is equal to the natural log of 2. So basically I take the natural log of this side and I take the natural log of the right side, and this is what we're left with. We can use our power rule, which then gives us x plus 4 times the natural log of e. Once again, what happens here? That goes to 1, so I'm just left with 1 times x plus 4 is just x plus 4. And we're solving for x, so subtract 4 from both sides. And we get x is equal to the natural log of 2 minus 4. That's the exact. If you put that in the calculator, the approximate should give you negative 3.3069. So this is your exact answer, and this is your approximate, plugging that in the calculator. Okay, so we take the natural log of both sides and then use this. So we get parenthesis x plus 4 times the natural log of 4. And then parenthesis 2x plus 5. Make sure you put that whole exponent in parentheses because they're binomials. Okay, and then here to solve this, we want to distribute this out. So we're going to get right there, that gives us x natural log of 4. And then this gives us 4 natural log of 4. So now we're distributing out our parentheses. On the right hand side, we're going to get 2x times the natural log of 5 plus 5 natural log of 5. Okay, Now, what's different about this one is we got to keep in mind where we're going. We're trying to solve for x. So what I would like to do is all of the terms with an x in them, we want them on the left side, and all of the terms that do not have an x in them, we want them on the right side. So let's rearrange our equation. Okay, so when we arrange it, we get this. The next thing we want to do is we want to factor an x out of this and an x out of this. So we want to factor an x out of this left side. Okay, so if take an x out of this one, I'm left with natural log of 4. Divide an x out of, factor an x out of this one, I have 2 natural log of 5. This side stays the same. My goal is to solve for x, so to get x by itself, divide both sides by this parenthesis. This is going to be our exact answer, and then we can carefully plug this into the calculator to get our approximate answer, which if you want to practice that, you should get approximately, actually this is 365, negative 1.365.